I am using my mouse today, as it seems when I use the longer chords, the sound does not work. So bear with the writing once again. All right, off we go. Have your vocab out, have some paper for notes, write down questions you have and things that really stick out that help you learn. Off we go. So proportional and non-proportional. You've heard proportional before. We talked about Ronald McDonald and his shoes, about his feet seem so much bigger than the rest of his body, and that would be something when we talk about proportional or not. So looking up here at our definitions, we have if two numbers are proportional, then they have a constant ratio. And this is where we're going to get into those constant ratio. We have ratios of comparison of two numbers. Constant means staying the same. For relationships in which this ratio is not constant, so those two quantities would be non-proportional. So if we change over time, you can do this with like how much do I earn over time, how much does a pizza delivery charge, a recipe is proportional as it changes per batch. Different things that change over time, if they remain constant, it's proportional. If they are not constant, it's non-proportional. So let's begin with some examples. So here, like I said, some delivering pizza. Uptown Pizzeria sells medium pizzas for $7 each, but charges a $3 delivery fee per order. Is the cost of an order proportional to the number of pizzas ordered? So it's really asking, am I really paying the amount like kind of the same? Is it going up proportionally or constant, the amount I pay to what I'm actually buying? So really throughout these ones, we're going to show you kind of the process of solving, and it kind of takes a little bit of work. You want to write some things down and you want to show things over time. So the first step would be to find the cost for 1, 2, 3, and 4 pizzas and make a table to display the number of pizzas compared to the cost. Okay, so you can do 1, 2, 3, 4, and you kind of want to do numbers in order just so it's easier to tell the difference. So you can make a table like this where you're comparing cost to the pizzas ordered. So if I order pizza, if I order one pizza, it's going to cost $10 because of that $7 for the pizza plus the $3 for the delivery. If I buy 2 pizzas, that's going to be 7 plus 7 for 2 pizzas for 14, and then another $3 for the delivery. Notice the delivery cost, that $3, only happens once because it's only one order. Even though I ordered 2 pizzas, it's the same delivery fee. They're not going to bring you a pizza, go back, and come back with the other one. They're only delivering the pizzas once. So same thing for the third pizza. You know, I do the 7 pizzas 3 times for 21, plus that additional $3 delivery fee for 24, and then 4 pizzas would cost $31. It's a little bit of math involved to make the table, and that's okay. It's not too difficult there. For each number of pizzas, you're going to write the relationship then of the cost and the number of pizzas, and you're going to write them as a ratio in simplest form. So notice they're saying cost and number of pizza. So we're going to kind of record those things in that same order. So cost over the pizzas ordered. So that would be, well, it's $10 for 1 pizza, which simplifies to 10. It's $17 for 2 pizzas, which simplifies to 8.5. And it's $24 for 3 pizzas, which simplifies to $8 per pizza is really what this is like. And $31 for 4 pizzas, which is $7.75, sorry. So what this means is that if you look on your book again, 194, this means that since the ratios of the two quantities are not the same, we go 10, 8.5, 8, 7.75, the cost of the order is not proportional to the number of pizzas ordered. If it had stayed the same, then it would be proportional. But in this case, because they are not the same simplified ratios, we are not or non-proportional. Woo, handwriting is so exciting. Okay, so take a second, maybe pause and record that information. Notice how you make a table in this case as well. Went away. Going on to the next page, for example 2, talking about a recipe for a fruit punch. So you can use the recipe on the right there to make a healthier version of a popular beverage, I'm assuming Kool-Aid, is the amount of mix used proportional to the amount of sugar. So it looks like we're going to be comparing the mix here to the sugar. So we're going to kind of go with that same strategy, and we're going to find the amount of mix and sugar compared. So we're comparing mix to sugar. So we know that kind of an input-output. So we make a table of this information. If we were to make one batch, we know it takes half a cup of sugar, 1 envelope of mix, and 2 quarts of water. So we continue making a table. Well, 2 batches, notice this is the second batch. You can kind of consider 1 batch, 2 batch, 3 batch, 4 batch, and everything's kind of multiplied. So it's going to take 1 cup of sugar because 2 half cups is 1, 2 envelopes because 1 times 2 is 2, and then 4 quarts of water because we doubled the 2. And notice that continues. So I'm adding, 2 every time because for every batch I need 2 quarts of water. I need 1 mix for every batch, and I need a half cup of sugar for every batch. So notice each one goes up. Furthermore, we're going to find the number of cups of sugar and write a relationship. So this is where we're really writing that ratio. We're writing that ratio comparing the 2 things that we're trying to find out. Because remember, a ratio is a comparison of 2 quantities. So we're comparing mix and sugar. So I compare my sugar to my mix, and I say, well, 1/2 of sugar goes with 1 envelope of mix. 1 cup of sugar goes with 2 envelopes of mix. 1.5 cups of sugar for 3 mixes, and 2 cups of sugar for 4 mixes. What I notice about this is I know 1/2 is 1/2 of 1. I know 1 is half of 2. I know 1 and 1/2 is half of 3. 2 is half of 4. So I notice that all of these do simplify to being the numerator is half of the denominator. So since all the ratios between the 2 quantities can be simplified to 5/10 or 1/2, the amount of mix is proportional to the amount of sugar. Since they all simplify to 1/2, they stay constant, the ratio stays the same, it is proportional. Maybe I'll highlight that for you because they stay the same. Give these next 2 in your book on 195 a try, and then pause and maybe come back and see how I did it as well. Okay, so you could do this one and this one. We'll scroll up and do the first one. So again, beverages, the same kind of concept with the fruit punch. So from example 2, now we're wondering if the sugar is proportional to the water. So we're kind of getting rid of this envelope mix piece. We're not going to pay attention to that. We're going to pay attention to the sugar and the water. So for this one, I could make, again, a table, and I'd be comparing, well, 1/2 to 2, 1 to 4, 1.5 to 6, and 2 to 8. So if I write these out as a ratio, I'm going to use my pen here. I have 1 and 1/2 over 2. That simplifies, well, half of 2 is actually the same as 1/4. Whereas 1/4 simplifies to 1/4. Maybe we're noticing a pattern. 1 and 1/2 compared to 6 is also 1/4. And you could use a calculator here as well. And then 2/8, hopefully we know that simplifies as well to 1/4. So what I'm noticing is that since, and I can type this out too, since the ratios all equal to 1/4, the number of cups of sugar, struggling to type here, is proportional to the number of quarts of water. And that's just a model how you would explain, because a lot of the questions will ask you to explain your thinking. And since they simplify to all the same ratios, they are proportional. Last one. At the beginning of the school year, Isabel had $120 in the bank. Each week she deposits another $20. Is her account balance proportional to the number of weeks since she started school? So I could make a table here to show the comparison of, time to, did it go anywhere? It's not working. To show the comparison of time to the balance she has. So we could think after 1 week in time, after 1 week, she started with $120 over here. After 1 week, she added 20, so her balance would be at 140. After the second week, she added 20 more, so she'd be at 160. After the third week, she added 20 more, she'd be at 180. And after the fourth week, she added 20 more, and she'd be at 200. So we're looking to find if the balance and the number of weeks is proportional. So I say, okay, the balance originally 140, does it out of 1 simplifies to $140, which is 140. The second week, 160 over 2, if it's proportional, should simplify to the same, and that simplifies to 80. 180 for the third week over 3 simplifies to 60, and 200 for the fourth week simplifies to 50. So what I see here, and again to explain it, what I see here is that since the ratios, I'll type this out again for an explanation, since these ratios are not all equal, her account balance is not proportional to the number of weeks since she started school. So hopefully you're finding a trend here that if the ratios simplify to the same, proportional. If they simplify not the same, then it's not proportional. Kind of an awkward video with the mouse and the sound. Hopefully it's working. Do your best. Make sure you go back, watch anything you need to. Check out someone else's video, book, personal tutor, all of those great things we have to offer for you. Write down 2 things you learned, 1 thing you're wondering, or vice versa. And we will see you in